Hello and welcome to part 2 of module 17 in our C language series. Today we're going to focus on the concept of the stack. Just a brief introduction. We know from earlier sessions as to how the stack works. And so we would place, for example, the first value onto the stack, then a second, a third, a fourth, and a fifth. Think recursion here. The fifth value would be the first one to be taken off the stack. Then the fourth, third, the second, the first one will be the last value to be used or taken off the stack, right? And so you can think of this as a stack of plates. Remember, the plate that was put first onto the stack is the last one that will be used. So keeping this in mind, what can we say about the stack? One, that it works opposite to the way a queue works, especially in terms of retrieval, right? Remember that when we're talking about retrieval, the queue works in a first in, first out order, whereas the stack works in a last in, first out order. Now, if you recall in module 14, when we discussed dynamic allocation, we spoke about how the stack is used to store local variables as well as function arguments. But which software is responsible for that storage? And to your mind would come the term compiler, right? And so we would say that the stack is used a great deal in system software, including compilers and interpreters. Now, what are the operations that can be performed in terms of the stack? And there are two basic operations, storage and retrieval. But how does that work in code? And so we will need two functions, push to place the value onto the stack and pop to retrieve a value from the stack. Important to remember that just as with the queue, the pop function retrieves the value from the stack and will destroy it if it is not stored elsewhere. Now, keeping all this in mind, let's go and write some code. Implement the store and retrieve operations in the context of a stack. And to do that, let's go to code blocks and we can start a new file. And we start with hashtag include stdio.h and then hashtag include stdlib.h and hashtag include stdbool.h. Okay, we have a hash define and max will be 5. And we define int stack. Remember, we're going to be looking at the stack as an array, and that will be max in terms of its size, right? 5 elements in the array. Then we have our function void push, right? This will place values onto the stack, so it will pass in an integer to be placed onto the stack. And then we have int pop, right? Essentially returning an integer from the stack. Okay, no arguments or parameters there. Int top of stack equal to 0 and bool overflow equal to 0. That's false. And bool underflow equal to 0. Now we'll have our main function, and within this we'll have int num equal to 10 and int return value equal to 0. Then we'll have a do while loop, and within this loop we'll call the push function sending in num, right? And then num plus equal to 10. So we are storing 10, 20, 30, etc. Right? Remember, this is just showing us how the stack works. We'll do this loop as long as or while num less than 100 and not overflow, as long as overflow is false. Okay, Once we're out of this do while loop, we'll have another do while loop. And in this one, we'll say ret val or return value will catch the value or the return value of the pop function. Then we check if not underflow. Remember, underflow is a Boolean type. Then printf %d popped off stack. So essentially, we will see which value has been taken off the stack. Right? Remember that value will be stored in return value or ret val. And this loop will continue while not underflow or while underflow is false. Again, underflow, remember, is a Boolean type variable. That finishes our main function. Now we write up push function, and that's taking in integer I, right? And within this function, we say if top of stack is greater than max, right, which means there's no more space on the stack or in the array, then printf stack overflow. And we change the value of the Boolean type variable overflow to true. So overflow equal to 1 and return. Okay. Otherwise, if this condition is not true, then we'll say stack of top of stack, right? So that's a subscript, or the index will be equal to I. Printf %d pushed onto stack \n comma stack of top of stack, right? So top of stack will be our index, and so it will print out the value stored at that particular position. And then top of stack plus plus to get ready to store the next value onto the stack, right? That completes our push function. Now we can write a pop function that's returning an integer, remember? So in pop, taking no parameters there. And within this function, we say top of stack minus minus. Now remember, we are retrieving values from the stack, right? Therefore minus minus. And after that, we can check if top of stack less than 0, which means now there's no more values left on the stack, in which case we can print stack underflow, right? That will be our message. There's no more values to be popped off. Change the value of underflow to true. Then let's return just a 0. Okay, otherwise we will return stack of top of stack, right? So that will be the index again. So this will return the value at this particular index. Now here we can check if not underflow and ret val not equal to 0. So let's run this now. And you can see we have 10, 20, 30, 40, 50, 60 pushed onto the stack. And then, of course, popped off the stack as well. but these are 6 elements, right? Our stack or array has space for just 5. So let's get our programming right. How do we do that? We can just say here, if top of stack greater than or equal to max. So now let's run this. And you can see now we have 10, 20, 30, 40, 50. Those are 5 elements or 5 values pushed onto the stack. And then 5 of them popped off as well. So this is exactly how the stack works. I hope it is clear. Right, now let's look at how the logic flowed in that program. We put 10 first onto the stack, then 20, 30, 40, 50. And then, of course, they were removed in a last in first out order. So 50, 40, 30, 20, and 10. Right? Now let's talk about the calculator as a stack. The calculators today use something called infix notation. So what does that mean? We provide an operand, then the operator, another operand, press the equal to, and we get our result. But earlier, calculators used something called postfix notation. So what does that mean? So here we would provide an operand, another operand, then the operator, and then of course we would get the result. Now how would this work in terms of a stack? Right, so we would have the first operand pushed onto the stack, then the second. Now the moment an operator is encountered, then these 2 values are popped off the stack, the operation is performed, and the result is then pushed onto the stack. Right, now keeping this in mind, let's write some code. So write code to implement a postfix calculator. Right, but how will the logic flow? The functions we will require will be the main function. Within this, we can provide the operands or the operator. Right, and then of course we'll have our push function. Remember, the push function will not have the operator pushed onto the stack, just the operands, and then we'll have our pop function as well. Right, so let's now go to code blocks and we can start a new file. We start with hashtag include stdio.h and hashtag include stdlib.h. Okay, and then we have hash define max, and that will be 100. Now we have an integer pointer, so in star ar ptr, and we're going to use this to allocate a region of memory that we can use. Then int star top of stack and int star bottom of stack. Okay, and then we'd have void push, which is our push function, and this will take in an integer I, and int pop, right, because pop is going to return an integer, no arguments there, okay, or parameters. Int main, and within the main function we'll have int a comma b, char str1, let me just put that of 80 bytes, and now we'll allocate memory. So r ptr equal to malloc size of, now we are allocating size of integer multiply by max, right, so that we can store 100 integers. So that's 4 multiplied by 100, and then we check if malloc returned a null. So if not r ptr, then printf out of memory and exit 1. after this, essentially, if malloc does not return a null, then we say top of stack or TOS equal to rptr, and bottom of stack equal to rptr plus max minus 1. Then we just have a message here, printf, and printf enter q to quit. Right now we'll have a do while loop. So do, and within this loop, printf enter number or operator. Hope you're with me, and then get as str1. Now we check the contents of str1. So switch star str1, right? And within this, we check case. If it's a plus operator, then we'll need to use A and called pop. We're getting that first operand. B equal to pop, second operand. Remember, we're using the postfix notation here. And then printf %d \n, comma, A plus B. Right? Then we need to push that result back onto the stack. So push A plus B. Right? And then of course break. Okay. Then we check case minus. So if minus is the operator, then again A equal to pop, B equal to pop to get the second operand, and then printf comma B minus A, right? And then push the result back onto the stack. So push B minus A and break. Right? Next operator, case multiply. Again, A equal to pop, B equal to pop, and print the result. B multiplied by A and push B multiplied by A. Okay, then break. And finally, we have the divide operator. So case divide. Again, get the first operand, the second operand, right? And then print the result. And place the result back onto the stack. So push B divided by A and break. Now we will have one more operator. Let's put in the dot there. And when this is entered, then what we will do is we will pop the latest value, or the value that is at the top of the stack, right? And remember, once we popped it, we need to push it back. Why? Because if, for example, it is one of the operands and we just pop it off, then it's not available to do the operation, right? So push A back onto the stack and print currently at top of stack is %d, right? Comma A, right? And then break, of course. Now the default will be push ASCII to integer of str1. Okay, so I hope that's clear. And this particular loop, this is the end of the switch, so the end of the loop is here. This particular loop will continue as long as or while star str1 is not equal to q for quit, right? So I hope that's clear. That finishes our main function. Okay, so now let's write pop. So int, or you can write push first, void push, and that's going to take in the parameter int I. And within this function, here we check if our ptr is greater than bottom of stack. Remember, bottom of stack is representing the last element that can be accommodated on the stack. And we say here printf stack full. Right? And return. Otherwise, we will just place it onto the stack. So star ar ptr equal to I. Right? So the integer goes onto the stack, and then we increase our ptr or increment it by 1, getting ready to place the next value onto the stack. That completes the push function. Pop function, remember, returns an integer, taking no parameters there, and we have our ptr minus minus. Remember, we are retrieving now from the stack if our ptr is less than top of stack, which means we have no more values to return. Then we printf stack underflow. Right? Return 0. Otherwise, return star r ptr. Okay, and that's all. That completes the code. I hope this is clear. Let's run this. Okay, there's no semicolon there. Enter number or operator. Enter another number or operator. Let's say plus 700. Now if I press a dot or I enter a dot, it's going to give me the value at the top of the stack, 700, right? So let's put in some other values, 200, 30, multiply, and there we have the value. If you enter a dot, it will give you the value at the top of the stack, right? And so on and so forth, right? So I can go on typing in values here, but I want to show you something. What if I don't push this value back onto the stack? That's here. So let's comment this out now and let's see what happens. If I enter a number, let's say 500, and then I press a dot. Okay, so now my 500 has gone off the stack. Let's say I enter 300 and I enter multiply. You see, I get stack underflow because that value was taken off the stack, and therefore I need to have this pushed back onto the stack once it is popped so that I have it ready to perform the operation. And then it works fine. Right, so enter 500, 700, let's say minus, right, so negative 200. What's on top of the stack? Negative 200. Enter another value, 30, multiply, we get the value, and so on. Press Q to end the program. Right, so you can play around with this program. This actually ends our session for today. In the next session, we will talk about linked lists. So till then, take care, stay safe. Bye.